Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. Today, inshallah, we are going to implement experiment 8, which is MOSFET amplifier circuit. The MOSFET that we'll see in our lab today, it consists of 4 terminals. And this is how you will see it, how you will see the device in the lab. You will see a cylinder with an edge, metal edge on it. And then we have a 4 terminal from the bottom. The 2 terminals around the edge, at the left and the right of the metal edge, these are the source and the body of the transistor. So the source and the substrate, or the body of the transistor, and the body here has no use at all in our experiment. That's why it is usually connected to the source. Usually the body and the source, or the substrate and the source, they are connected together for the whole experiment. And then we have 2 other legs. When we move counterclockwise, okay, then we'll find the gate and then the drain. So this is how you will see the device in the lab. Usually the substrate and the body, or the body and the source, they are connected together. That's why you will see that they are working as one wire together in the experiment. The circuit that we are going to implement today, we are going in the first step to implement the DC part of the circuit, which consists of a DC source, 10 volt, then a resistance RD, which is 5.6 kilo ohm, then the transistor, this is the drain, this is the source, and the gate. There is a feedback resistance from the drain to the gate, RG. This is a feedback resistance with a very high value, usually 1 mega ohm. And then the source is connected to the ground. This is the first part of our experiment, where we implement only the DC part of our circuit. And in the first part, we are required to measure all DC measurements. So we are going to measure the current ID and the current IS. They are supposed to be the same because the gate current is 0. And then we'll measure also all the voltages, all the DC voltages, VD, VG, and VS. And then once you do these measurements, you need to confirm that the transistor is biased in the right or the correct amplifying region, which is the saturation region. So you need to confirm saturation, or sometimes we call it pinch-off region. How to confirm this? We need to confirm that VDS, the voltage VDS between the drain and the source, is greater than VGS minus V threshold. And V threshold here, practically speaking, for the MOSFET, V threshold, it ranges between 1 to 5 volt, between 1 and 5 volts. You can consider here to be 1.5 volt, take it as 1.5, and you need to confirm this equation. So this is the equation needed to confirm that the transistor is biased in the saturation region, and hence we can use it as an amplifier. This is the first step of our experiment. The next step is to connect the rest of the circuit, which will be a capacitor. And the capacitor, again, it's an electrolyte capacitor, which you need to be careful of the direction. So the positive should be connected in this direction and the negative in this direction. This is C1, okay? And then a resistance, RS. Then this is our input source, VS. And our input source will use the function generator to generate 100 millivolt peak to peak, okay, with 10 kilohertz. This is the input source. So this is the input part. The voltage here is called VS, and the voltage between this point and the ground, we'll call it VS2. So this is VS, this is the voltage at this point is VS2. And the output, we are going to take the output from the drain and we are going to connect a capacitor here, positive this side, negative the other side. This is C2, and C1 and C2, both of them are 22 microfarad. So this is 22 microfarad, this is 22 microfarad, and then we are going to connect our load here. This is our load, 10 kilo ohm, and this will be our output voltage. So this is the complete circuit using the AC part and the DC part, okay? And then we are going to do now some AC measurements. We are going to measure some gains, and we are going to study the behavior of the transistor as we increase the input voltage. So the first gain that we are going to measure, we'll call it A1. A1 is a ratio between V output peak to peak and VS2 peak to peak. So what you are required to do now is you need to connect channel 1 of the oscilloscope between this point and the ground. So let's plot the ground. So this is channel number 1 of the oscilloscope, and you need to connect channel number 2 of the oscilloscope at V output, between V output and the ground. So this is channel 2 of the oscilloscope. You measure the peak to peak of the output voltage, peak to peak of VS2, then you divide them over each other, you will get a gain called A1. Okay? Before we continue for all other gains, we will need to study the behavior of the MOSFET amplifier here. Of course, you expect the output, if the input is a sinusoidal wave, you expect the output to be a sinusoidal wave too, right? So the output should look like an amplified sinusoidal wave, something like this. What happens if we increase the input? If we increase the input, you expect the output also to increase, right? But at certain point, the amplifier will be saturated, which means that the output will saturate it to not be able to increase more than a certain level. And here we say that the output started to be clipped, right? So if you keep increasing the input voltage above 100 millivolt, if you keep increasing this, the output will keep increasing too. But at certain point, it will start to be clipped like this, either from the top or from the bottom. So what you will need to do here is you will keep increasing the V input, Vs, here, until you find that the output starts to be clipped. At this point, you stop and you say that this is the maximum input voltage that can be amplified without clipping. So you will keep increasing Vs until you notice that the output voltage started to be clipped either from the top or from the bottom, and then you stop. At this point, once you notice the clipping, you stop and you measure the value of Vs. This will be the maximum input voltage that can be amplified without clipping. At the same time, you can, at this point, you can also measure Vs2 maximum, and you record these values in your report. After this, we'll measure two other gains. We'll measure a gain called A2. The gain A2 is defined as the ratio between the output and peak to peak of the output voltage over the peak to peak of Vs. So the difference between A1 and A2 is that A1 is the ratio between V output and Vs2, while A2 is the ratio between V output and Vs, not Vs2. Also, we'll measure another gain, A3. A3 is again a ratio between V output, peak to peak, over Vs2, peak to peak, but when we remove our load. So in the third step, you are going to remove our load. Okay, make it open circuit here. So we'll make this part like an open circuit. Okay, and then you measure the ratio between V output and Vs2. This will be called A3. So here without our load. So now we have three gains, A1, A2, and A3. Similar to the previous experiment, we can use these three gains in order to calculate the input impedance of the amplifier and the output impedance of the amplifier. And we can use the following equations in order to calculate these impedances. The first equation is R input over R input plus RS equals A2 over A1. Of course, we calculated A2 and A1, we measured them, and we already have RS. RS is the value of this resistance, okay, which is used as 10 kilo ohm. So we know RS. So from this equation, you can calculate the value of the input impedance of the amplifier. Then the second equation is, I'm going to remove this part here. The second equation is R load over R load plus R output, this is the output impedance of the amplifier, equals A1 over A3. Already we measured A1, we measured A3, we know what is R load. R load is 10 kilo ohm, and then from this equation we can calculate the value of R output. And that's it for our experiment today. I wish you good luck.